Okay, Assalamualaikum warahmatullahi wabarakatuh. So now I'm going to talk about inverse variation. Okay, so in this subtopic we have three learning standards. First is to explain the meaning of inverse variation, to determine the relation between two variables for an inverse variation, and third, to solve problems involving direct variation. Okay, first the definition. Inverse variation explains the relation between two variables such that when variable y increases, then variable x decreases at the same rate and vice versa. This relation can be written as y, whereas inversely as x. Okay. So if previously in direct variation we have when y increases, then the variable x increases at the same rate. So now we have an opposite situation. Okay, mind memorization 5, textbook page 17. Page 17. Where's page 17? Okay, here. Okay, to explain the meaning of inverse variation. Okay, understand the following situation. A school hall has a few doors. The table below shows the relation between the number of doors open, x, and the time taken for a group of pupils to leave the hall. Okay, so as you can see, as the number of doors open increases, the time taken for the students to leave the hall getting shorter. Okay, so this is an example of inverse variation. The more number of doors open, the shorter time taken for students to leave the hall. Okay, so here this relation is known as inverse variation. Example 15. Okay, Chairming takes part in a 42-kilometer marathon. The table below shows the relation between the time taken by Chairming and his average speed. Okay, so hours, 4 hours average speed 10.5 km per hour. For 8 hours 5.25 km per hour. Okay, so look at the table. Okay, when the time taken is longer, the average speed becomes smaller. Okay, so it says state the change in average speed if the time taken increases by 2 times. So when the time taken increases by 2 times, what happened to the time taken, to the average speed? The average speed decreases because the time taken increases. Okay, it's opposite. So the time taken decreases by 1.5 times, so the average speed increases 1.5 times. Okay, look at the table. Okay, next example 1 here. So I have 4 values of x, 1, 2, 3, 4, and 4 values of y. Okay, the corresponding y. When x is 1, y is 24, 2y, 12, 3, 8, 4, 6. Okay, so given that the value of xy are all 24, so what we can say here, the xy is a constant. Okay, the constant is xy. So we say that y varies inversely as x. So we write y varies inversely 1 over x. Okay, so y equals to k over x. So k equals to xy lah. Okay. Next. So when we say y varies inversely as x, so here is the variation relation. Okay, we use 1 over reciprocal. Okay, y equals to kx, and also we say x and y are inversely proportional. Okay, so in direct variation we have this y and x is a y versus x is a straight line graph passing through the origin. Okay, now for inverse variation, we have y versus 1 over x, having a straight line graph passing to the origin. For y versus x, we have a hyperbola graph, okay, because of the reciprocal here. Okay, next. Okay, just now y varies inversely as x. Now we have x to the power of n. What happened? Okay, so it's the same as the one we had before. It's just you have the power of n for x. So for variation relation, you just write x power of n here, and then you substitute the relation, the proportional symbol with equals to k, and then the graph doesn't change lah. It's just the horizontal axis belongs to x to the power of n. Okay, so this one, just now we had xy equals to 24, so y equals to 24 over x. Okay, because the question asks you to express y in terms of x. Okay, we have the constant xy 24, so y equals to 24 over x. The k is 24. Okay, next, example 17 and 18 from textbook. Okay, let's try doing example 17 and 18. Example 17. Example 17. Two quantities x and y vary based on the table on the right. By using a suitable scale, draw the graph of y against 1 over x. Okay. So x, y, 2, 4, 5, 10, 2, 4, 5, 10, 8, 4, 8, 4, 3.2, 1.6. Okay. Draw the graph of y against y versus 1 over x. So we need 1 over x. Okay. 1 over x. So 1 over 2, 1 over 4, 1 over 5, 1 over 10. So draw the graph. So you need the graph paper. Okay, you need graph paper. So I just sketch, but you need to draw. Okay, draw means must use graph paper. Okay, so y versus 1 over x. Okay, y, so the biggest is 8, so 0, 2, 4, 6, 8, 0.1, 0.2, 0.25, 0.5. Okay, so 0.1, 0.2, 0.3, 0.4, 0.5. Okay, then you plot lah. First 1.6 here, 0.25 here, 1 over 4, 0.25, 0.25 and 0.25. So it's not here. Y 3.2. Okay, somewhere here, somewhere here. 0.5, y equals to 8. So looks like you got a straight line. Okay, straight line joining all this. Okay, the graph is a straight line that starts from the origin. Okay, example 18. Example 18. Okay, x equals to 0.25 when y equals to 3. Y in terms of x, y varies inversely as x. Okay, so y equals to k over x, y equals to 3k 1 over 4. So 3 times 1 over 4. No, 1 over 4. 3 times 1 over 4. It's 0.75k. So y equals to 0.75 over x. Next, y varies inversely as the square root of x. B, y varies inversely as square root of x. So y equals to k square root of x. Y equals to 3. Okay, 1 over 4 becomes 1 over 2 over 2, 3. 0.5 times 3, 1.5. So y equals to 1.5 divided by the square root of x. Okay, so that's example 17 and 18. Next, what do we have next? Example 21 from textbook. Okay, according to Boyle's law, the gas pressure P of a mass of gas is inversely proportional to the volume of gas. Okay, so P proportional to V, inversely proportional to V. So P equals to kV, right? Calculate the volume of the gas when the gas pressure inside cylinder 1 to 1.76. Okay, so first we need to find P in terms of V. So we got to find K first. So K is 15220 P. Okay, then substitute P to find V. Okay, the pressure is 1 to 1.76, and then you substitute for 1 to 1.76 for P, and then you just divide 15220 divided by 1 to 1.76. You got 125 centimeter cube for the volume. Okay, that's all for inverse variation. So if you have anything to ask, just ask me during the lesson. Bye bye.